Let's look at secant and cosecant. Now, because secant and cosecant are paired with sine and cosine, we basically use the same restrictions. So for secant, I'm going from 0 to pi halves and pi halves to pi, which would be quadrant 1 and quadrant 2 angles. Basically the same as cosine, because secant is the opposite of cosine. So here is our visual restrictions, and here is when we flip them and get the arcsecant graph. Finally, we have cosecant, which goes from negative pi halves to 0 and 0 to pi halves. So quadrant 1 and negative quadrant 4 angles, which is basically the same as sine, because cosecant is the opposite of sine. So there's our cosecant graph restricted, and here's what happens when we flip it to get the actual cosecant graph. So let's add these to our domains. Cosecant, negative pi halves to pi halves, just don't include 0. Secant, 0 to pi, just don't include pi halves. So cosecant, negative pi halves to 0, 0 to pi halves. Basically the same as sine, just don't include 0. Secant, 0 to pi halves to pi. Basically same as cosine, just don't include pi halves. Now let's look at the cosecant and secant inverse graphs and look at their domain. So here's my cosecant graph. My domain looks like from negative infinity up to negative 1, and then from 1 to infinity. And those ones are included. So negative infinity up to 1, or sorry, negative 1, and then 1 to infinity. And for arcsecant, same thing, negative infinity up to negative 1, and 1 up to infinity. And those are all of our domains, which keep handy because you will use them in a couple minutes for some problems. So let's start with some unit circle problems. Start with arcsecant equals arcsecant of 2, which would be the same thing as secant of theta equals 2, which would be the same thing as cosine of theta equals 1/2. It's a lot easier to think of these in terms of sine and cosine because that's what we're used to on the unit circle. So I go to my unit circle and think, where is my x value? 1/2. Those two triangles have an x value of 1/2. So that's going to be at pi thirds and 5 pi thirds, or negative pi thirds. And because it's the opposite of cosine, we use the same rules. So let me check. Secant, I did yellow. That means I don't want that one because cosine and secant are the quadrant 1 and quadrant 2 angles. So I really just want pi thirds as my answer. So having done an example like that, I want you to try the arccosecant example. Rewrite it, find it on the unit circle, restrict the domain, and then write your actual answer. Pause the video and try that out now. Let's check your work. So we have sine of theta equals negative 1/2. That's what I converted it to. So we want where the y value is negative 1/2. That happens at 7 pi 6 here and 11 pi 6, or negative pi 6. And since arccosecant is paired with sine, we use quadrant 1 and negative quadrant 4. So I don't want that one and I don't want that one. I want my negative quadrant 4. Gives me negative pi 6. Okay, let's move on to a canceling one. Now, we know that this arcsecant and secant will cancel as long as that 5 pi 4ths is in the secant domain. So secant domain is the opposite of the cosine, so it'll be the same domain. Cosine is quadrant 1 and quadrant 2. That means 5 pi fourths is not in the domain. 5 pi fourths is right here, which is not in quadrant 1 or quadrant 2. So let's find the other triangle that is. So if this is 5 pi fourths, and we're thinking here of secant, which is the cosine, we want to find the other triangle that has the same cosine value. So that should be right there because cosine is x. Both of those triangles share the same x value of negative root 2 over 2. This angle up here is 3 pi fourths. So because the 5 pi fourths did not work, I know that 3 pi fourths is the one that will work. So that's my answer. Okay, last one for this video. Let's try one where we build a triangle. So same 3 steps as before. Use the inside to build your triangle. Use that to build where your triangle is. Step 2, use Pythagorean's theorem to finish your triangle. And then step 3, find the cotangent of that triangle. So pause the video, try that one out on your own, and then come back to check your work. Let's see how you did. So sine is y over r, so I need my y value to be -1, my r value to be 3. These are the 2 triangles that fit that description. Both have a y value of -1 and an r of 3. However, because this is cosecant, aka the opposite of sine, I'm going to restrict it to quadrant 1 and quadrant 4. So I don't want that one. So I've got my triangle. Now step 2, use Pythagorean's theorem. To finish your triangle, I get plus or minus root 8. I want the plus because the x is positive here. And then finally, step 3, we want cotangent, which is x over y. So the x value is a positive root 8, y value is a -1 to get our final answer. So that is your introduction to arcsecant and arccosecant. In the last video for this lesson, we'll do some questions with variables, and then you'll be done.